In an electrical service installation, the grounding electrode connection is a critical aspect for safety and compliance with electrical codes. In the specific scenario of an 800 amps 480 volts enclosed circuit breaker feeding an 800 amps bus cutter, which in turn feeds a 200 amps non-fused safety switch, then a 200 amps meter base, and finally a 200 amps main breaker panel board designed to accommodate more than 6 tenant spaces, the grounding electrode should be connected to the 800 amps enclosed circuit breaker enclosure. The grounding electrode's primary function is to provide a connection to the earth, offering a low resistance path for any fault currents. This connection ensures that in the event of an electrical fault, the current will safely flow to the ground, tripping the overcurrent protection devices and minimizing the risk of electrical shock or fire. The 800 amps enclosed circuit breaker can be considered on the supply side of the service. This is because it is the first point of connection for the service entrance conductors. Being on the supply side has significant implications for how the system is bonded. One important aspect is that the utility neutral can be used as the bonding conductor. The utility neutral is typically grounded at the transformer, which provides a reliable grounding path. This means that the neutral conductor from the utility acts as the primary means of carrying fault current back to the source, ensuring a low impedance path for effective clearing of faults. In addition to the grounding electrode connection, several other bonding connections are essential to ensure the electrical system's overall safety and integrity. Firstly, the 800 amps enclosed circuit breaker enclosure should be bonded to the 800 amps bus gutter. Secondly, the 800 amps bus gutter should be bonded to the 200 amps non-fused safety switch. Thirdly, the 200 amps non-fused safety switch should be bonded to the 200 amps meter base. Fourthly, the 200 amps meter base should be bonded to the 200 amps main breaker panel board. These bonding connections create a continuous electrical path, ensuring that all metallic parts are at the same potential, which minimizes the risk of electrical shock. Compliance with the National Electrical Code, known as NEC, is paramount in any electrical installation. The configuration described complies with NEC requirements for grounding and bonding service entrances. Specifically, NEC Article 250 addresses grounding and bonding requirements, mandating that the grounding electrode be connected to the service entrance conductors ahead of any disconnecting means. This ensures that the grounding system is always in place to provide a safe path for fault currents, regardless of whether the disconnecting means are open or closed. NEC Article 310.15 allows the use of the utility neutral as the bonding conductor when the 800 amps enclosed circuit breaker is deemed to be on the supply side. This provision recognizes that the utility neutral, being grounded at the transformer, provides a reliable and low impedance path for fault currents. Grounding electrode conductor sizing is dependent on the size of the service entrance conductors. For example, if the service entrance conductors are 500 kc mil copper, the grounding electrode conductor must be at least number 1 or alt copper. You will need to review NEC Table 250.66 to ensure proper sizing. Also review NEC 250.24c, which allows the neutral conductor to be used for grounding and bonding on the supply side. The neutral must be sized per NEC 220.61. Also, the grounding electrode must be connected to the neutral at a readily accessible location per NEC 250.24a. The purpose of bonding is to create a low impedance path for fault current. The purpose of grounding is to connect the electrical system to the earth. The grounding electrode system can consist of several types of electrodes. These include a metal underground water pipe, a concrete encased electrode, a ground ring, or rod and pipe electrodes. If using rod or pipe electrodes, they shall not be less than 8 feet in length and 5/8 of an inch in diameter. The location for ground rods must be free from physical damage. When multiple services supply a building, only one grounding electrode system is required. Each service must have a grounding electrode conductor run to this system. The grounding electrode conductor is used to connect the grounding electrode to the electrical system. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. Bonding jumpers are used to connect metallic parts of the electrical system together. The size of the bonding jumpers is determined by the size of the service entrance conductors. The purpose of bonding is to create a low impedance path for fault current. A lower impedance path allows fault current to quickly return to the source. This quick return of fault current causes the overcurrent protection device to open, clearing the fault. The requirements outlined in the NEC, such as those in Article 250 and 310.15 Bernier, are designed to ensure electrical safety by providing a clear and effective path for fault currents to return to the source, thereby minimizing the risk of electrical hazards.